Hi everyone, this is Mrs. J, and today we're going to talk about perimeter and area on a coordinate plane. So the perimeter of a polygon is the distance around the polygon. So to find the perimeter, essentially all you need to do is find the sum of all the lengths of the polygon sides. If the side lengths aren't given, we can always find them using the coordinates and using the distance formula. So in example 1, they ask us to classify this quadrilateral to UVW, then find the perimeter rounded to the nearest tenths. So let's start by plotting our points. 1, -2 is right here. 4, 1, 2, 3, and -1, 0 is W. Okay, so first we could check to see if this is a parallelogram by seeing if both pairs of opposite sides are parallel. So here we see that the slope of WV, so we can say up 1 over 1, up 1 over 1 is +1. We can see that the slope of TU is also 1. So we've just concluded that WV is parallel to TU, so we can show that on our picture. Now let's check the slopes of our other pair. So the slope of WT is down 1 over 1, down 1 over 1, so it's -1. The slope of VU is also -1 if you look at the rise over run. So that means that WT is parallel to VU. So that means that we could classify this. One way we could classify it is a parallelogram. Another thing you'll notice since we have the slopes is that we can see that WV and WT have opposite reciprocal slopes, which means that they are perpendicular. So WV is perpendicular to WT. WT is perpendicular to TV, and these are also perpendicular, and so are these because of their slopes again. So we see that we have 4 right angles because they're all perpendicular, which means that we could also classify this as a rectangle. Now to check to see if it is a rhombus, one way we could do this is by seeing if all 4 sides are the same length, and we need to find the lengths anyways to find the perimeter. So let's start finding the length of all 4 sides. Okay, let's start by finding the length of TU, and again we're going to use distance formula. So we could do x2 minus x1 squared plus y2 minus y1 squared. And again, this does say rounded to the nearest tenth, so we could just plug these into our calculator. So if you plug this into your calculator, you get approximately 4.2 if we're rounding to the nearest tenth. Okay, now let's find the length of UV. So same thing, we can do distance formula. X2 minus x1 squared plus y2 minus y1 squared. Plug it into your calculator, and here we get approximately 2.8. Since we know that it is a parallelogram, we know that the opposite sides are congruent, so that means that WV will also be 4.2, and WT will be the same as UV, so it will also be 2.8. Since all 4 sides are not congruent, we know that this is not a rhombus, but we do have enough information now to find the perimeter of this quadrilateral. So again, to find the perimeter, we simply add up the 4 side lengths. So 4.2 plus 2.8 plus 4.2 plus 2.8. So our perimeter is 14 units. Okay, so now we're going to start talking about area. So the area of a polygon is the amount of space that's inside the sides of your polygon. So one thing, there's different formulas for different areas of depending on which type of polygon you have. But for all of these, whenever you have your final answer, we always measure area in units squared. So that's a really important thing to remember. So here, first, we know the area of a triangle can be found using 1/2 base times height. The important thing to note is that our height must be an altitude, meaning that it must be perpendicular to whatever we are using as our base. So for a rectangle, it's just base times height, so no big deal. But for parallelogram, it's a little bit different. It is base times height, but we need to make sure again that this height is perpendicular to our base. So it's not just going to be the length here times the length here. We're doing base times the perpendicular height. For a rhombus, the area can be found by doing 1/2 d1, which is the full length of one diagonal, times d2, which is the full length of another diagonal. So 1/2 d1 times d2. Kite can be found in the same way. And last, a trapezoid is 1/2 times the sum of your bases. So make sure you know which sides are your bases, times the height, which again needs to be a perpendicular height between your bases. So you can see for each of these, the first thing you're going to need to do is determine which type of polygon you're working with so you know which formula to use. Okay, so here, let's try this one together. We have more of an application-based problem here. So this says Colby is planning and costing, which means he's kind of making out like a cost analysis of an ornamental garden in the shape of an irregular octagon. So each unit on the coordinate grid represents 1 yard. He wants to surround the garden with decorative stones, which cost $7.95 per yard. What is the total cost of stones he needs to purchase? So our strategy here is going to be to find the perimeter of this garden. And then once we know the perimeter, we can find the total cost of the stones by multiplying the perimeter by the cost per yard. So again, we're going to start with the perimeter. I'm going to zoom in a little bit. So here, any place where you see a horizontal or vertical line, those are nice perimeters because we can actually just count them. So we know, for example, that both of these have a perimeter of 2. But anything that is not perfectly horizontal or vertical, we are going to need to find that length either using the distance formula, or since we've been doing distance formula a lot, we can also use Pythagorean Theorem. So for example, to find the length of AH, we can make a right triangle that looks like this, and we could say, okay, AH squared equals A squared plus B squared. So this length is 2, and this length is 3. So 2 squared plus 3 squared. So AH is going to be the square root of 2 squared plus 3 squared. And for this, we are going to use our calculator to get a decimal approximation rounded to the nearest tenth. So for this one, we would get approximately 3.6 yards. So now, being strategic, if this is 3.6, I know that AB is also 3.6 because if I make a triangle, it's the same right triangle. It's a 2 by 3 with the legs. So we know that this is also 3.6. And then for the other ones, again, we can kind of be strategic. Here, if I'm finding the length of BC, I can create a right triangle that has legs 2 and 5. So we can find that. So we can say BC squared equals 2 squared plus 5 squared. So BC is going to be the square root of 2 squared plus 5 squared. So here we get approximately 5.3 yards. And we know this one already. And so now being strategic, if I look at like the length of CD, I see, oh, if I do Pythagorean Theorem, it's a 2 by 5. It's that same triangle. So I know that this must also be 5.3. Again, because it's the same right triangle. Same thing here for ED. It's a 2 by 5, so this must also have the same hypotenuse, 5.3. And then the same thing here. This is a 2 by 5, so this would have the same hypotenuse of 5.3. So now to find that total perimeter, we're going to add up all the sides. So you could just list them all and add them, or we could be strategic. I see that I have two lengths of 3.6, so I do 2 times 3.6 plus I have 1, 2, 3, 4 lengths that have 5.3, so 4 times 5.3, and then I have two sides that have a length of 2. So this will give us the perimeter of this ornamental garden. So this gives us 32.4 yards. But again, he wants the cost of lining the garden with decorative stones. So again, to do the cost, we're going to do the total number of yards he needs to cover times the price per yard, which is $7.95. So this gives us a total of, here we'll get $257.58. So that's how much it would cost for him to line the garden with those stones. So now here we have the same garden, it's just a new picture, so we have more space to work with. It says Colby also wants to lay the whole garden with turf, which costs $3.25 per square yard. What is the total cost of the turf? So here we're actually going to need to find the area of the inside of the garden, and then we're going to multiply that by the cost per square yard. So with this, it's really important that you're strategic in the way that you find your area. So again, if you can find a way to divide this up into shapes you know with horizontal or vertical lines, that would be best. If you can also make shapes that have the same dimensions, it will be easier for you to find the area. So for example, here I was able to make a 2 by 5 right triangle, another 2 by 5, another 2 by 5, and another 2 by 5. So then if I find one area, I know all of them. And then up here, I can make a triangle ABH. And then what I have left are just two rectangles. So if you split it up like this, it might make it a little bit easier. So let's start by finding the area of this right here. So again, since it is perpendicular, we can just do 1/2 base times height. This is a perpendicular height, so the area of that triangle, again, 1/2 times your base, which you can call this or this, it doesn't matter, so 2, times your height, which is 5. So the area of that triangle is 5 yards squared. And so that's going to be the area for all of them that have those same dimensions. So this is 5, 5, 5, and 5. Now for the triangle up here, I see that we have a base of 4. Remember when we're doing the height, we do need to make sure we use a perpendicular height, which would be right here. So in this case, our base is 4 and our height is 3. So the area of that triangle is 1/2 times 4 times 3, which is 6 yards squared. So this is 6. And then these are rectangles, so you just do base times height. So here 4 times 2 is 8. And here we have 1, 2, 3, 4, 5, 6, 7 by 3, which is 21. So again, to find that total area, we're going to add up all of the individual areas. So we have 4 regions that have an area of 5, so we can do 4 times 5 plus 6 plus 8 plus 21. So here our total area is 55 square yards, so yards squared. And that means to find the total cost, can we do our total area times the cost per square yard, Make sure we have a dollar sign because it is in dollars. And if you multiply those together, you get $178.75. So that's our total cost. All right, so now we're going to keep practicing find the area of different polygons. So let's look at example 3, which says find the area of the triangle with vertices A, which is -4, -2, B, -2, 2, and C at 5, 1. So remember, the trick when you're finding the area of a triangle is 1/2 base times height, but the height needs to be perpendicular to the base. So it looks like the easiest perpendicular height to find would be connecting B to line AC. So we need to find a perpendicular line here. So we can start by finding the slope of AC so we can figure out what the slope of the perpendicular line is. So the slope of AC, if you look at it and we do rise over run, we see that it's 1/3. So we know that the slope of the perpendicular line should be -3/1. So if I start at B and I go down 3/1, that leads me to right here, which happens to be on line AC. So now we have that perpendicular height that we need, and I'll call this point D. So now we need to actually find the length of our base and our height. So we could do that with the distance formula or Pythagorean theorem. So I'll do distance formula. So for AC, again, we know the coordinates here and here. So we can do the square root of 5 minus -4, so plus 4 squared, plus 1 minus -2 squared. So if we're going to round to the nearest tenth, we get approximately 9.5 units as the length of AC. So now we need to find the length of BD. So we know that D, the coordinate of D right here, is -1, -1. So again, we could do the distance formula or we could do Pythagorean theorem, either way. So I'll do distance formula. So B to D, we can do -1 minus -2, so plus 2, and then -1 minus 2. So again, we'll get a decimal approximation. So here we get a length of approximately 3.2. So now that we know the length of our base and height, we can plug it finally into our area formula. So area is 1/2 times our base, which again is AC, times our height, which was BD. And here we get approximately 15.2 units squared because it is area. Okay, let's move on to example 4. So here we are asked to find the area of the quadrilateral with vertices 1, -2 at T, 4, 1, which is U, 2, 3, which is R, and F, which is -1, 0. So again, for us, it's going to be important to know what type of quadrilateral we're working with, so we can figure out if we need to do a parallelogram area or if we can just do base times height. So we are going to need to know that the opposite sides are parallel, and we would like to know if this is a rectangle because that would make it a little bit easier. So again, we could figure all this out by finding the slopes of all the lines and comparing them. So if you start with the slope of TU, if you do rise over run, it's +1. The slope of UR, so here, remember we always go from left to right, so it's actually -1/1. The slope of FR is +1, and the slope of FT is -1. So this tells us a few things. It tells us that the opposite sides are parallel, meaning it's a parallelogram, but also you'll notice that the consecutive sides have opposite reciprocal slopes, which means they're perpendicular and also means that all of these angles are 90. So this is actually a rectangle. Since it's a rectangle, we just do area is base times height. So quickly we are going to need to find, again, the length of our base and our height. So we can do TU. So imagine that I'm going to do Pythagorean Theorem here. So this leg would be 3, and this leg is 3. So we do the square root of 3 squared plus 3 squared. So we get approximately 4.2. And then for RU, again, let's imagine we did Pythagorean Theorem. So it's 2 by 2. So it's the square root of 2 squared plus 2 squared, which is approximately 2.8. So my area is just going to be the base times the height. And again, we can do this because we know that it's a rectangle. So our area here is approximately 11.8 units squared. So again, it depends on how we're rounding. So my calculator for this one told me that it's 11.76, which, remember, if we're rounding to the nearest tenths, we would round that up to 11.8. Just a quick reminder on rounding. For the tenths, you look at the hundredths place, and if it's 5 or more, we round the tenths up 1 unit. Okay, let's move on down to example 5, where we're working with some more quadrilaterals. So here, it's important again to note what type of quadrilateral this is, and this is a trapezoid. And I can see that because I know that the one pair of opposite sides are parallel, and these are not parallel, so this is a trapezoid. So that tells us that we're going to use the formula 1/2 b1 plus b2 times the height, which must be perpendicular. So this is one of our bases, so we can call this b1, and that length is 6. We could call this b2, and this length is 5. And then this line is perpendicular to both of my bases, so we can actually use this as our height, and this height is 3. So now we are actually ready to use our formula. So we do 1/2 times the sum of your bases, 6 plus 5, and then times your height, which is 3. So here our area is 16.5 units squared. Okay, let's look over here at this next one. Again, I should have added this into the pictures. Let's assume that this is a trapezoid, and so those two lines are parallel, and let's assume that these are 90-degree angles. So again, we're going to use that trapezoid formula for area. So 1/2 times the sum of your bases times your perpendicular height. So I see that I have one base, and we can call this B1, and I can see that we have our perpendicular height. But what we are missing is our second base, B2. So strategically, we can find this total by taking this part, which we know should be 8, because the top base is 8. So from here to here, EC is 8. And then we can actually find DE, which I'll call X, using the Pythagorean Theorem, because here we have a right triangle. So we can say x squared plus 8 squared equals 10 squared. So x is going to be the square root of 10 squared minus 8 squared. So that x value is 6. So that means that B2 is just going to be 6 plus 8, which is 14. And now I have everything we need to use our area formula. So we take the sum of the bases, and we multiply it by the perpendicular height, and then we divide it by 2. And we get an area of 88 units squared. Okay, so let's move on to this figure. So looking at this figure, I can see that these two, this pair of opposite sides are parallel because they're both horizontal. If I look at this slope, the slope of BC is 1, 2, 3, 4 over 1. Slope of AD is also 4 over 1. So I see that we have a parallelogram. I can see that it is not a rhombus because the four sides are clearly not congruent. And I see that it's definitely not a rectangle because those are not 90-degree angles. So it is simply a parallelogram. And we know for a parallelogram, we can do base times height, but we just need to make sure that the height, again, is a perpendicular height. So here I could see that our base is 6 units. And then our height, again, pick any altitude that is perpendicular to this base. So I see that this is 4. So our height is 4. So the area is just 6 times 4, which would be 24 units squared. Okay, we just have a few more examples to go. We are almost done. So in figure D, again, let's determine what type of quadrilateral this is. Since the consecutive sides are congruent, I see that this is a kite. So remember, the formula for the area of a kite is 1/2 times the product of your diagonals. So this one is easy enough because I can see that this diagonal is 12 and this diagonal is also 12. So the area of this kite is 1/2 times 12 times 12, which gives us 72 units squared. Okay, moving on to this one. Again, we know it's a kite because the consecutive sides are congruent. So we're going to do, again, 1/2 times the product of the diagonals. So here we know that one diagonal is 20, but we need to find the length of the other diagonal. And so another thing that we know about kites is that the diagonals are perpendicular to each other. So that means that here we have a right triangle. So we can find this, and once I know this, I know that this will also be the same length. That's another property of kites, is that exactly one diagonal bisects another diagonal. This is clearly not bisected, so this must be bisected. But let's start by finding that x value. So we could do 13 squared equals x squared plus 12 squared. So x is going to be the square root of 13 squared minus 12 squared. So x is going to be 5, which means the total diagonal is 10. So here, to find the area, we do 1/2 times 20 times 10. So it is going to be 100 units squared. Okay, and these are the last two. So we're finding the area here again. So for this one, it's kind of similar to that garden one we did. We're going to try to break it up into different pieces that are easy enough for us to find. So I see if we break it up like this, we actually have a square here. So it's going to be base times height. So 4 times 4 is 16. For this triangle, it's going to be 1/2 times, I'll use this as the base, and we can use this as the height because it needs to be perpendicular. So 1/2 times 4 times 3 will be 6. Here I can see that we have a triangle. These are perpendicular, so we can do 1/2 times this base times this height. So 1/2 times 2 times 4 is just 4. And last here, we have another right triangle, so we can do 1/2. We'll use this as our base and this as our height. So 1/2 times 4 times 4 is just 8. So to find the total area, we can just take the sum of the smaller areas. And this gives us a total area of 34 units squared. Okay, in this last example, I'm going to offer a different way we can approach this one. So the reason why is that if you try to break this up into shapes that you can find the area of, we kind of have an issue over here because there's no nice way to make an easy triangle, and I try to avoid making lines that are not vertical or horizontal, although technically it could work. It's just a little trickier. So just strategy wise, there is something else we can try. So rather than finding the area of all the things inside, what we could do is we could kind of give ourselves a larger region that encompasses all of it. Let me do this in red. So imagine I kind of drew a large rectangle like this. It encompasses my entire shape. So if I take that total area and then I subtract out the part that I don't want, which would be the stuff on the outside, I can subtract this away. Then that would leave me with the area of the polygon that I'm trying to actually find. So, and if you look at these shapes, these might be a little bit easier for us to find the area. So again, this is just a different strategy that you could try. So it might be a nice one to explore. So let's try this together. So if I find this total area, I see that I have a rectangle that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So the total area is 7 times 5, which is 35 units squared. From here, we need to find the area of what's in gray, so we could subtract it, leaving us with the area that we want. So I can start right here. I have a right triangle, so I can do 1/2 times 1 times 1, 2, 3, 4, 5, 6, 7. So that gives me an area of 3.5. Right here, I can do 1/2 times 2 times 1, 2, 3, 4, 5, 6. So that leaves us with an area of 6. And here we can even break this down a little bit more, maybe like this. So we do 1/2 times 1 times 3, which gives us an area of 1.5. And then here, this is a rectangle, it's 2 by 1, so this has an area of 2. So again, now that we have those areas, we can take our total area of this large rectangle that we created, and we can subtract away the parts that we don't want. And that leaves us with a resulting area of 22 units squared. Okay, that is all for today's video. Thank you so much for watching.